The Real Estate Group New York reports that the mean monthly rent for a one-bedroom apartment without a doorman in Manhattan is $2,668. Assume the standard deviation is $489. A real estate firm samples 99 apartments. What is the probability that the sample mean rent is less than $2,725.01? All right, so what we need to notice here is that we're being asked about the probability of a sample mean being in a certain range rather than an individual apartment rent. So we need to use the central limit theorem if possible. The central limit theorem says that if the original population is normally distributed, or if you have a sample size greater than 30, then your sample means will be normally distributed with a mean that matches the original population mean and a standard deviation that starts with the original standard deviation, but then you divide by the square root of the sample size. So if the sample size is greater than 30, we don't even have to check if the distribution was normal. If the sample size is smaller than 30, then we have to look and see, well, was the original population normal? Because then you're still okay. So let's see, what is the sample size here? It says a real estate firm samples 99 apartments. So that's plenty large enough for the central limit theorem to hold, regardless of whether or not the original population of apartment rents is normal. It doesn't matter. We already have a big enough sample. So now we just need to answer the question here. What is the probability that the sample mean is less than this number? So our mean here, the original mean, is 2,668. The standard deviation is 489. The sample size is 99, which means that the standard error, the standard deviation divided by the square root of n, is 49.146349. So we're going to use that standard deviation to figure out the probability. So the value that they've given us here is 2725.01. Now, if we were talking about an individual apartment, that value would translate to a z-score that would be found by taking the mean, or not the mean, the x value first. So that value that was in our cell A8, this number here, minus the mean and divided by the standard deviation. So then we would have a z-score of 0.12. The area to the left of that could be found using norm dot distribution with the x boundary, the mean, and the standard deviation. And of course, always true for cumulative. And the right area would be found by using the complement, 1 minus the left area. So that's what we're used to doing. But since this problem is a question about not an individual apartment rent, but a mean of 99 apartment rents, we should use a different approach when finding the z-score. The z-score would be, instead of dividing by this standard deviation, we should divide by the standard error, which is the original standard deviation divided by the square root of n. Then we get a different z-score. And same thing when we use the normal distribution. we would still use that X boundary, we would still use this mean, but instead of picking this standard deviation, we would choose the standard error and then 1 for cumulative. So that does give us a different answer. And if we didn't understand the difference between finding a probability regarding an individual apartment rent versus the sample mean of 99 apartment rents, we would have had the wrong answer here. So I'm confident that this is my answer. I'm going to go ahead and enter it 0.8851. But let me double check. Did it ask for the probability to the left or the probability to the right of that number? What is the probability that the sample mean rent is less? Okay, good. So I wanted the left area. I was so confident. And here it is incorrect. Let me find out why. Pause. Okay, it was a simple typo. For some reason, when I typed in this number, I had typed 2727.01 or something like that. What was it? Yeah, that was what it was. So that's how I was getting the wrong answer. If I just change this so that it's a 5 there instead of a 7 here, then everything is a-okay. And I had my correct answer of 0.8770.